Hello friends, in this video we will learn how to configure static NAT on ASA. This is our topology. Please understand the IP addressing and topology correctly, then start the configuration. We have R1, R2, R3, R4, ASA1, VLAN 10, 20, 30 and 40. Let's start with VLANs. We required VLAN 10, 20, 30 and 40. Go to switch. No VLAN 2000, VLAN 10, 20, 30, 40. R1 in 10, 2 in 20, 3 in 30, 4 in 40. R1 in 10, 2, 20, 3, 30, 4, 40. Do show history. R1 in 10, 2 in 20, 3 in 30, 4 in 40. Now we have to configure ASA 0 by 0 in 10, 20, 30, 40. Do show VLAN brief. Done. VLAN configuration complete. Now we have to go to R1. R1 enable show IP interface brief conf t interface F0 by 0. No shut. IP address is 1.1, 0 by 1, 192.168.101.1 and loopback 1 and 2. Interface loopback 1, IP address 111.1, IP address 222.1. Do show IP interface brief. 1.1, 101.1, 1.1, 101.1, 111.1, 111.1, 222.1. Done. Then we have to go to R2. .100. Its gateway. Done. 10.100 gateway 10.1. We have to configure here telnet and SSH. IP domain name shiva.com, crypto key generate RSA 1024, line VTY 0 to 90, transport input SSH telnet, login local, username Shiva, privilege 15, secret Shiva. Do show history. Then we have to go to R3. Interface F0 by 0. Interface 0 by 1. Okay. Do show history. Then we have to configure telnet, SSH, HTTP and HTTPS. IP domain name shiva.com, crypto key generate RSA, line VTY 0 to 90, transport input SSH telnet, login local, IP HTTP server, IP HTTP secure server, IP HTTP authentication, local, username Shiva, privilege 15, secret Shiva. Do show history. Done. Then we have to go to R4, R4, F0 by 0, its IP address is 20.100, gateway, any IP, any mask 20.1, 20.100, gateway 20.1. Then we have to enable here HTTP and HTTPS. So copy these commands. Done. R1 ready, 2 ready, 3 ready, 4 ready. Then we have to go to ASA OS version 9.6.1, enable conf t, hostname ASA1, interface gig 0 by 0, no shut, name if inside 1.2, IP address 1.2, 0 by 1, no shut, name if DMZ1, security level 60, IP address is here 10.1, 10.1, gig 0 by 2, no shut, name if outside IP address, public IP address here. For internet, route outside any IP, any mask, default gateway, gig 0 by 3, no shut, name if DMZ2, security level 50, IP address 20.1, show int IP brief. 1.2 10.1 public 20.1, 1.2 10.1 public 20.1, show route outside, show route outside. We have default route toward the ISP. Now we have to configure EIGRP on R1 and ASA. Go to R1, R1, router EIGRP 100, no auto summary, network, any network you have, advertise that in EIGRP. Go to ASA, router EIGRP 100, no auto summary, network is 192.168 1.0, 192.168 1.0, 10.0, 20.0, redistribute static, metric, bandwidth, delay, load, reliability, MTU, show running config, router. Done. On ASA, we have advertised 1.0, 10.0, 20.0, 110.20, redistribute static, show EIGRP neighbors. Done. Show route inside. Yes, 101, 111 and 222. Go to ASA, check the reachability with inside PC, ping to 1.1, 101.1, 101.100, yes. ASA is capable to communicate with 101.100, with 10.100, with 20.100, with remote PC. Done. Again we can verify ASA to PC1, ASA to R2, ASA to R4, ASA to PC2. Done. Now what we are going to do? We are going to configure here static NAT. Look at the topology. We will configure static NAT for R1, 1.1, for R1 lane, for PC1, for R2, for R4. Go to ASA, create object network R1. R1 is having IP address 192.168.1.1. Host 1.1, R1 lane 101.1, object network PC1, 101.100, object network R2 10.100, R4 20.100. Show running config object. Yes, you have to create object R1, R1 lane, PC1, R2 and R4. R1, R1 lane, PC1, R2, R4. Now we have total private IP addresses 1, 2, 3, 4, 5. So for static net we required 5 IP addresses. So object network IP1 host 101, 2, 102, 3, 103, 4, 4, 5, 5. Show running config object. Done. Then you have to go to object network R1. We will NAT it. When traffic will come from inside, it will go to outside. We will perform static with IP1. We will translate R1 with IP1. Same object network R1 lane. We will perform NAT. When traffic will come from inside, it will go to outside. Static with IP2. Object network PC1. We will NAT it. When traffic will come from inside, it will go to outside with IP3. Then object network is here R2. We will perform NAT. When traffic will come from DMZ1, it will go to outside. Static with IP4. We will perform, go to object network 4, NAT. We will perform NAT. When traffic will come from DMZ2, it will go to outside. Static with IP5. Done. Show running config object. Show running config NAT. Object network is R1. We will perform NAT. When traffic will come from inside, it will go to outside. We will perform static NAT with IP1. Object network R1 lane. We will perform NAT. When traffic will come from inside, traffic will go to outside. We will perform static with IP2. Object network is PC1. We will perform NAT. When traffic will come from inside, it will go to outside with static with IP3. Same for object network R2. R2 we will perform NAT. When traffic will come from DMZ1, it will go to outside. Static with IP4. Object network R4 we will perform NAT. When traffic will come from DMZ2, it will go to outside. Static with IP5. So excellent. Done. Now go to R1, access to R3, go to R1, ping to ISP. Ping will not work, but telnet working. Go to R2, ping will not work, but telnet will work. Go to R4, ping will not work, but telnet will work. Same, you can go to PC1. This is PC1 IP addressing. You can check here 192.168.101.100, 192.168.101.100 CMD. Telnet. First of all check ping. Ping will not work, but telnet, username Shiva, password Shiva, working. Go to ASA. Commands are in front of you. Show running config object. First create object. Show running config NAT. Define NAT. So xlet to check. If you want that ICMP traffic should be allowed. So what will happen? Traffic will go higher to lower, but reverse it will not come. ICMP traffic is not stateful, so what we have to do? From any source, open access list out, permit ICMP any for object R1, lane PC1, R2, R4, access group out in interface outside. Permit ICMP from, we know very well, traffic. When traffic will go into out, source will be our lane, destination any, reverse. Source will be any, destination will be R1 lane, PC1, R2 and R4. Permit ICMP any from any source to these object, then apply it at the in interface outside. Go to R1, ping 2, yes, working, go to PC1, working. Okay. Static NAT is bidirectional. Put command so accelerate. When traffic will come from inside, ESA will translate 192.168.1.1 into this one. But when anyone will hit to this IP, ESA will translate it with this one. So what we have to do? We have to initiate traffic from lower to higher. Hit to, we want to access which one? We want to access this telnet server. So 10.100 is the IP, check its public IP, 10.100. We have to hit 104. So go to PC2 102.1.1.100 CMD telnet to 104. Not working. Reason: higher to lower is allowed, lower to higher not. We have to open ACL, go to ASA, access list out, permit TCP any object R2 equal to SSH telnet for R4 equal to 80.443, permit TCP any object PC1 equal to 21. Yes, so history. Any can come to object R2 telnet SSH for R4 HTTPS and for PC1 FTP. For R2 SSH telnet, for R4 80.443, for PC1 21. Again initiate request from PC2. Go to PC2, working, HTTP. Yes, we have to hit which IP address? Go to ASA, so accelerate. If you will hit 104, you will get access of 10.100. If you will hit 105, you will get access of 20.100. If you will hit 103, then you will get the access of this one. Let's try one by one. 103, 104, 105. Go to PC2, CMD telnet to 104, working, HTTP to 105, username Shiva, password Shiva, working, HTTPS to 105, working, and FTP to 103. Yes, because 101.100 is netted with 103 and here FTP is running, so we will hit this IP with FTP. Yes, combo software collection we can download. Okay, it's working. So this was our static NAT. Clear, configure, NAT clear configure access list clear configure object. Show running config object no, show running config NAT no, show running config access list no, clear xlist. Thank you.